this model, which is a lot more robust than just the very simple neural network that we looked at last time.
Yes.
That you just have one path through.
Yeah.
And here you go through a process multiple times, but then that process then feeds into another process. And and as we said last time, the whole purpose of this is to try as best we can to model how our brain works.
Yes.
And our brain, we still don't know exactly how our brain works, but we do know that we have billions of neurons that all feed to each other. It's not a linear process.
3, 2, 1. Welcome to Love Machine.
Welcome to another episode of Nerding Out with That Nerdy Catholic. I'm Seth Payne, and I'm here with my co-nerd Cesar. And last week we looked at the neural network, the artificial neural network, and we talked about the basic structure that all artificial intelligence is built on top of. And today we're going to go a little bit deeper, and we're going to look into what is a large language model. This is what most people think of now when they think of artificial intelligence. ChatGPT and Ollama. There's so many large language models out there, and that's what we're going to be talking about today. But before we jump into that, I want to let you know, if you go to thatnerdycatholic.com, you can sign up for our email list to get updates on when we put new things out. For this series specifically, if you go to thatnerdycatholic.com/AI, we will have a list of all of the episodes that we've done in this series. But there's also a form. If there's any thoughts you have, that is a really great place to put in. If you know of anyone that works in the industry that you think would be great to talk to, let us know in that form. Any topics you want us to cover in this series, let us know, and that will have an impact on what we do in the future and what we talk about. You might say that would be, you would be training our artificial intelligence network.
Yep.
Because sometimes I don't feel like I have a lot of natural intelligence. So if you head over to thatnerdycatholic.com/merch, you can get cool t-shirts and mugs, things that we've designed, and that's a great way to support this channel. You can also head over to thatnerdycatholic.com/support and give us financial support directly, and we appreciate all support that you have given us over the last year, and we're just excited to see where we're going to be going. Now, last episode, I said that that would be the last time that we're going to be taping in person, and Cesar and I looked at his schedule and realized we were able to fit in one more in-person taping. So this really is the last time in person, and then we're going to have an adjustment time in the next couple of weeks, and then Cesar and I will be starting up our recording again remotely, and so you will see the split screen with the two of us. So, Cesar, let us jump into large language models.
Sure. So one of the things that everybody sees right now is that, well, I can talk to ChatGPT, but what is actually doing, no? So behind the scenes, what we have is a predictor of the next word. No? So you start a text, and then what the machine does is, having this amount of text, what is the best word to fit at the end? No? And then we repeat that. So once the machine have the next word, it repeats again the same cycle, predicts the next word. And if you have powerful GPUs, well, that prediction goes fast, and it have the sensation that you are actually talking to a machine, and the machine is answering to you, no? Which is at all the impression for us, but behind that is just the best prediction for the next word each time the machine put a word while we're speaking, no? And that is the basic understanding of what is an intelligent system that talks to you, quote unquote, here, no?
Yeah.
That's the large language model in simple terms, no? It's the same as if you have, a pattern of figures, and you try to, those intelligent exams that you have pattern of figures, and which one is the next pattern,
Yeah.
and you have to guess that. It is the same that the machine is doing here, but with words, no? Of course, you can take when you see that those intelligent, quote unquote, intelligent tests for people, there's let's say a mathematical pattern that our brains pick it up and then applies the next pattern correctly or incorrectly. And that is a nice word, because machines can also write the wrong thing.
Right.
No?
Well, as we talked about last week, when with the simple artificial neural network that we looked at, when you first create the network, there's random values in there.
Yeah.
So you're going to put in something intelligent, and you're going to get out gibberish. And the process of, we talked about last time, the process of training the model is you have a bunch of answers you already know, and then you put something in, you get something out, and then you compare it to what it's supposed to be, and then you have to tweak things.
Yeah.
And the machine in this process will have the answer, and the machine will then say, okay, given my output, given what it's supposed to be, let's tweak all these parameters, and then try again.
Yes, exactly. No, and right now, but even though and you can see that if you are very into any of the large language models, just probably open Microsoft Copilot, ChatGPT, Apple Intelligence, whichever is your favorite, you will see that sometimes a phenomenon called hallucination. No. So what's hallucination? It's not like the machine is imagining things.
It's not that they're on drugs.
It's not that they're on drugs. It's the fact that when they start to answer, the correct word didn't start at some point, no? The correct answer. They start with some sort of answer, but because they are going that cycle by cycle, they reinforce that, and you have actually an hallucination. Because remember, the machines doesn't think. They just are very good at discovering patterns and try to go the next pattern that matches the input that best matches the input that they have. No?
It's kind of like if you're doing a math test, you have this long equation, and you start out, you write out the equation, and how do you solve an equation? You start doing some of the calculations within the equation. You start grouping, like variables, all that. If in the first step you make a mistake,
you will carry on.
That mistake is going to go all the way to the end.
Yeah.
And you're going to get the wrong answer.
Yes.
And the whole process might be the correct process. But if you mistake an X for a Y in the first step, then that mistake is going to bring you all, go all the way to the end.
That's a nice analogy, actually, So it's so let's start with we mentioned that in 2017 Google published Attention is All You Need, and they described the method for the large language model based on a new transformer architecture, which is what we are going to basically focus this time. No, the idea with this transformer architecture is going to at that time they used to translate from English to German, I think that's it, and they proposed that architecture, and with this architecture they were able to do faster and more accurate translations. No, in the large language model world, each word is or it's called also a token. So that's why you said tokens here. Each token it's represented in n-dimensional space vector. No?
Mhm.
So, and that token, it's, let's say, safe in the machine that has n-dimensional spaces in a place. No, so we can imagine that this multidimensional mathematical space has all the words grouped by, let's call it, similar words with similar meaning will be in that space closed than other words with different meanings. No? So, and of course, for us, getting a dimension more than 3 is really hard to picture. No.
Yeah.
Nevertheless, n dimension, but mathematically that is possible. As an abstract mathematician, you can work with that. No, if you have studied in the university calculus, it's easy to work with n-dimensional variables that you never can picture in your mind, but you can calculate around that. No?
Well, as we said last week, a big part mathematically of neural networks would be the matrices. So you have these large matrices with all these variables in it, and that each element, each item in the matrix is another dimension in this model. These groupings of words, I'm assuming that's you get those groupings through the training model, right?
Yes, that groupings of word happens on the training model. That groupings of word are grouped like that after you pass the first pre-trained model and get ready for the answer there. And these groups of word are, as I said, joined by meaning, basically. No, so similar word with similar meaning goes together, and let's say words with opposite meaning are complementary or in this space. No, so there is an axis for, I don't know, let's say plural and singular, masculine or feminine, and there are several axes in this n-dimensional space that you can go from one to another in order to find the. Of course, we don't see that, no, but once we start digging into the what is inside the machine, you can only imagine how that will look like.
Yeah.
There are, so that is basically what happened in a large language model. No, the key word here is model. No, and the model, the more parameters the model has, the more words, the more training, the more input. It's the biggest model. And of course, the bigger the model is, the more intense the task for the GPUs or whatever other processor you use to try to find the answer. No.
Yeah, I remember when you first helped me get Ollama set up on my computer, looking at the different models that you could download. One of them is 500 megabytes. One is a couple gigabytes. One was a few tens of gigabytes.
Yes,
pretty big.
Yes. And usually in a normal computer, let's say a standard laptop, they are really going to hassle. If there's a model that is more than 8 billion parameters, there are 500 billion parameters. Those models are for the cloud. No, your computer is really.
You're gonna need a really big server type machine to run those.
Yes, exactly. So an AI have two main functions. No, we talked about a little in the last episode. The first one is machine learning, which is the process that you have your model and you want to train it in order to have significant outputs for every input. No, and the final product of that is a pre-trained model. No, and this is an important concept. Pre-trained model means that you have a model that is useful, but you can also personalize. No, and this personalization is going to be done in a later process that we are going to see in a moment. No, but then there's the inference function. No, so once you train the model, the inference function means that given a quantity of text, what is the next probable word that is going to be in the next text? And that the inference function is the most that we final user use in order to talk with a large language model. No, so for this, you need some PC with a lot of memory, a GPU, or an NPU. That's why the Macs that has an NPU are really good doing those. No, with this you can just run a model, and a small model that can fit inside your computer. No?
Yeah.
If it's a big model, you probably run it on the cloud. No, by querying to the cloud.
Yeah. You have this large language model, as you said. You have these groupings of words based on their meaning. So you have this network of these groupings of words, and it's almost like it's a dictionary, or maybe more like a thesaurus.
Yeah.
Thesaurus. So you have these groupings of words, and then the inference model is then the program that you use. If you sit down and you start typing, it's going to look at the words that you're typing, and then it's going to start looking up all the words in this model.
Yes.
And then it's going to try and predict what comes next based on the words that are close to it.
Yes, that's correct. No, and we are going to see in detail right now when we explain the transformer architecture. Let's just understand each one of their components here. No, the input embedding layer, which is the first one that you see. The unique thing of this layer is that they took the whole, not just one word, but the whole sentence as an input, no, or the whole paragraph, whatever you do, no. So this is a very important characteristic because instead of words, as I said, this language model use the word tokens. So depending on how many tokens your input layer can handle, is the biggest the paragraph or the biggest the context you can give it to the model, no. So this is very important. No? The more specific you are during that in that initial input, is the better the chance that you have for the predictor for the next word, no? And the less chance of hallucination. No? So that embedding layer is going to have the whole tokens in parallel, and this is the key word, in parallel, as an input. It's not going to read one word by one. It's going to grab the whole thing in parallel, and it's going to start the processing of the whole paragraph with all the tokens inside in parallel. No? That's the embedding layer. No. Then in the picture we see multi-head attention. No, but the attention has mainly two ways. There's the multi-head attention, and there's also the self-attention. Since this diagram is taken from the paper Attention is All You Need, which is available online.
We'll put a link to that in our description.
Yes. Yeah. In that case, the example that they are giving is the example of having entering the word in English or a paragraph in English and translating into another language. No? Since there is a one-by-one correspondence, no, that's a multi-head attention, because you are not in this case, you are not trying to predict the next word coming from in English. You are trying to do a parallel between the words in English and the words in Germany. So they need two sides, let's say two sets of different tokens. No, the tokens in English, the token in Germany. So that's why they use multi-head.
Okay.
When you are talking to a chat box to start talking to predict to the next word, that's self-attention, because you have tokens in English, and the answer is going to be the same space of tokens in English.
Okay.
So self-attention is the second part of this neural network.
Mm-hmm.
And what self-attention is doing is, okay, I have these words. What I'm going to do is, for example, if I only have the word, let's say, check, no? Check could be something that is good.
Mm-hmm.
Or, for example, check could be a defect in a container.
Mm-hmm.
Check
Could be something you write to give money to
Exactly.
someone. Yeah.
Exactly.
Yeah.
Then what is the correct meaning of that word? You are going to compare the other words
Yeah.
to find, the correct meaning in this context of check is this one.
Mm-hmm.
In order to do that, I'm going to do a self-attention. I'm going to compare my word in this paragraph
Okay.
against the other words in the same paragraph
Okay.
to grab the right meaning so I can find that correct place in my large language model.
You're trying to find the context within the greater
Exactly.
the sentence or paragraph. Yeah.
Exactly. That is the multi-head attention. Then there's a feed-forward part here, no? The feed-forward part, in this layer, what we are going to do is, once we have the correct meaning of the input words, we are going to start searching and comparing with the knowledge already into our database. No? Once we already discuss the correct meaning of the input words, we are going to start comparing that with the knowledge of the database. And this process starts to repeat, no? Self-attention, feed forward. Self-attention, feed forward, no? There's another layer, which is at and norm layer. So in math, these vectors are between 0 and 1, basically, no? So whenever that matrix multiplication finish, obviously there are some bigger numbers than 1.
Yeah.
No? So this layer, what it does basically is just standardize to a number corresponding to 0.
You make sure you just do a transformation
Yes.
on all the output numbers that you have to make sure that they fit with between 0 and 1.
That's correct, sir. Yeah. That's correct. No? Then we have the linear transformation. This is basically at the end, no? At the end of all the processes, because you go from attention to feed forward, attention to feed forward several times. No? At the end, we have a linear transformation. And this is basically having the last column of the matrix, let's call it, the last word. At the end of this process has almost all the meanings that it needs to predict the next one. No? So the last thing is what is need to be done is to have a number, for that meaning that's a linear transformation. And the softmax is the last part that goes from, okay, this is our last transformation that is going to go from 0 to 1. That's it. No? Then after that, you go to the output layer that, again, transform those numbers into the next word.
Okay.
No? The output embedding layer, which is number 7. And then you see that from the output embedded layer goes again, because you again are going to repeat that process to find the next word, the next word. No?
Well, and so as you said at the beginning, all these things go in parallel, right? And so is this actually happening at the same time? Is this process happening in parallel?
So what is happening in parallel is the processing of the whole word or the whole paragraph that you write.
Yeah.
But so the whole paragraph comes and goes to the feed forward, to the embedding, then to the multi-attention, add a norm, feed forward, multi-attention, add a norm, feed forward. But as a whole thing, it doesn't go word by word.
Right.
That's what I meant when it's processing in parallel.
Right. No. Well, thinking about using this for translation, and thinking about what translate, like Google Translate, when it first came out, it was okay. But it felt like it was just going through linearly.
Yeah, word by word.
And it was translating words, but it wasn't doing a great job at making it sound good in
Yes.
another language.
Yes.
I've been going through, Duolingo. I knew Spanish before, okay, but I've been trying to get better at it. And when you speak more than one language, you realize that one, the word order is not the same.
Yes.
And if you try to, I've tried this before. If you just literally translate each word, it's not going to make sense.
Yes.
So you need a more robust model to say, here are the words. Here's what the words translate. Here's what the meaning is, like you were saying with check. Here's the actual meaning of the word. Here's what the translation of that word is. But then you have to have the next level to say, okay, well then how do I actually say this
Yes.
in that other language? And you can't just do a step
by
through
one.
one by one, translate this word, this word, this word, this word. You were saying, you have groups in these models, and I'm assuming then if you have like an English model and a German model, you have lines between the two with meanings, but then you don't just translate words, you translate the meaning of the whole sentence.
That's correct.
Yeah.
That's correct. And this is why this AI translating model are much better than the older Google Translate. I'm sure they are improving Google Translate to use this right now. But, in the days back then, you see the horrible translation. If you know the language, the other language, you see, what? Okay, I see what you want to say, but that's not exactly, no.
Yeah. Well, and so you see now this model, which is a lot more robust than just the very simple neural network that we looked at last time.
Yes.
That you just have one path through.
Yeah.
And here you go through a process multiple times, but then that process then feeds into another process. And as we said last time, the whole purpose of this is to try as best we can to model how our brain works.
Yes.
And our brain, we still don't know exactly how our brain works, but we do know that we have billions of neurons that all feed to each other. It's not a linear process.
Not at all. Yeah. We know that it's not a linear. We don't know exactly how it works. That's correct. No. We would like to have some key definitions, just to set the ground for future videos. No. So, in order to have a good conversation about AI, we need to know what is a large language model. And I think we accomplished that. No? Large language model are, for example, ChatGPT 4. Right now, the new one is ChatGPT 5. No, we have Grok. Somebody will say Copilot is no. Copilot is not a large language model. If you understand, and I invite you, open your Copilot and say, on which large language model are you based on? And Copilot will answer you. This is the large language model. We will see what is Copilot. No. The next definition is the agent. No. So the large language model, what is actually is only let's say, the set of numbers that it could be astronomically big, that is embedding all the words in this multidimensional space. No, that's per se the large language model. No, the agent is the software that allows us humans to interact with large language model. Right. So those are agents. For example, ChatGPT. Let's say Apple's artificial intelligence. No. Ollama is another agent. No. This allows you to interact with a large language model. No. The agent per se is the link between the human and the large language model. No.
Well, and as we've been working on Ollama. We each have Ollama on our computer, and when you install it, you install the agent, and then you download whatever model you want.
Yes.
And so then when you actually launch Ollama, you say, on the command, you open up a command line, you launch the agent, and then in the command line you say which model you want to use.
Yes, that's correct. Yes. And that is for example, Seth mentioned Ollama, and Ollama has a lot of small language models that can fit into our laptops. No? So if you go to ollama.com, you will see models there. And the models that are below 8 billion parameters, you can fit in your laptop if you have a good laptop, of course. No, you at least has to have 16 gigabytes of memory, a very good GPU, or a very good CPU can do it, but it can do it slowly. No, but that's a small language model. A large language model is the ones that are hosted in the cloud. The small ones, for example, let's say Llama is the small language model for Facebook, for Meta, no? And there are, 500 billion parameters Llama, which you cannot fit in your computer, but there are also the 8 billion, 7 billion, 1.5 billion. Those are the ones that you can fit in your computer and download. The beautiful thing here is that you don't need an internet. Once you download the model, you don't need an internet connection. To do that, no?
Well, and so that's the one that I've been playing with for a while now. And one of the things that we've used Ollama for, and with the Llama model, is so whenever we put out a video, I do all the editing, and then upload the video to YouTube. One of the things that YouTube does with its background processing, it does an auto generate of the closed caption file. I download the closed caption file, so I have a basic script of everything that we said during the video. I'll open up Ollama and say, okay, here's everything we said in the video. Give me a 10-sentence summary. And so then that goes through, as we've described, through the language model and says, okay, here's everything you said. Try to find all the meaning and do its best to give a summary. It's a really great starting point for getting a good description for the video.
That's right.
Email, text, and it always needs some editing because sometimes it sounds odd. Sometimes it puts emphasis in the wrong place. But it's a great place. It's a great tool to say, just give me something to start with.
Yes.
Instead of sitting there saying, oh, what are all the things that we said? How's the best way to summarize it?
Yes. No, that's a very good a good use of Ollama, no? So we were talking that GPT stands for Generalized Pre-trained Model. So how do you continue training and refining that model? That is a process called Retrieval-Augmented Generation, or RAG, no? This is a technique that enhances a large language model, no? The outputs by combining them with information retrieved from external knowledge sources, no? So if you have a large language model, but you want this model to be a specific knowledge about any topic, you provide more information.
So let's say medical, for example.
Yes.
Would you try and feed in all the medical journals?
Yes.
As an example.
So you go through this model and you do the RAG process, and then the model will capture the medical knowledge into it, and it's going to be a more expert medical model that you have, no? So that's the beautiful of these models. Although I have to say, if you want to do RAG, you need some kind of powerhouse GPUs in order at some time to do
Well,
this.
as we said, last time that one of the companies that's been very successful in because of AI has been NVIDIA, because they're the one that most people
Yes,
use the NVIDIA chip
to do
for their
this.
processing.
Exactly, that's true. No, then we have two more definitions. The one is local AI, the one that you can run in your computer, and it doesn't talk to the internet at all. It's all in your computer. You can be offline and you can still talk to the model. No, the local AI, it's a very good place to start if you don't want your information be shared in the cloud. No? The only thing that is a setback on local AI is because it's not connected to the internet, it won't be able to catch any final news, any final the developments that it has in the final days. No, it only has the information until it was created, and that's it. No. On the other hand, the cloud provided AI are very powerful, easy to access. You just need a laptop and a connection to internet, and you have all the information, what is new there. The only disadvantage is that you probably don't have, you are sharing your own information also to the cloud to everybody.
Well, and you are, everything that you do is also training the model.
Yes.
Because the model itself, especially with GPT, is always being updated.
Yes.
It's always being refined, right?
The important thing here is the agent. In a local AI, like let's say Ollama, you control the agent. You know what the agent is doing. No? When you sign up to Copilot, Apple Intelligence to dig into the cloud with that, you don't control the agent. You must say the words, but the agent is a software outside the model that allows you to interact. Could also be sending information about, okay, this is the most request words that we are using. In this locality, they are asking a lot about this. So you don't know exactly what the agent is doing. No? So that's I want to be specific in this context, because there are some people that there is some concern about the privacy of the information. So if you are more on that, the recommendation is to use more local AI. But again, if you use more local AI, you will miss the latest development.
Yeah. Well, but it is updating, not real time.
Yes.
I mean, I've noticed that as I've used Ollama, there's on my Mac there's a little icon on top, and if I see a little arrow on the icon, it says, you need to download the latest model.
The latest model, yes, exactly.
Yeah.
All right. That's what we have.
That's a great overview. So where are we going to go from here? So last episode in this episode, we gave a very general overview. As we said last time, we're not actually going into the math.
Yes.
The math can get very, very complicated.
Yes.
And so, once again, if you go, we'll share again the URL to the 3 Blue 1 Brown video series done on this, because they do a really great job, not just looking at what we've looked at, the kind of overview and structure of AI, but there are videos, because it's a math channel, they go into the math a lot, pretty deeply.
Math lover, we strongly recommend to see that.
Yeah.
Yes.
So where are we going to go from here? So what we want to do, we want to look at what are the implications of AI with our faith, with just how we use it. What's a good way to use artificial intelligence? What are the implications of artificial intelligence as far as, so how to use artificial intelligence? We want to look into some issues of ethics with artificial intelligence. And so, as I said before, if you go to thatnerdycatholic.com/AI, we have a form on there. If you've run into any ethical issues with AI, one of the ones that Cesar just mentioned is using the large language models like ChatGPT, where you're doing it on the cloud. You don't know every single word that you type in. You don't know what they're using, what they're doing with that information. So they're privacy concerns. What are some other ethical issues that you've thought about, that you've encountered with artificial intelligence? So we want to do some videos looking at ethical issues with artificial intelligence. But we also want to look into some of the issues of the metaphysics around artificial intelligence. One of the episodes, at least one episode we want to do, is looking at all of the words around that we use with artificial intelligence. You look at stories in the news, and some of the words that are always used with artificial intelligence: thinking, deciding, training. These are words that in our own lives mean one thing. In artificial intelligence, they mean another thing. But it is very easy to hear those words and say, "Oh, artificial intelligence, they're saying it's thinking, therefore it must be like another person." As we said last time, or a couple episodes ago, we have an image in our mind of robots from Star Wars, or from this image from The Matrix. In popular culture for decades now, we've had this image of these robots or machine or any kind of machine that can get to the level as a human being. And that's the way a lot of people are treating it as well. People are treating ChatGPT like it's a person that they can talk to. So we want to look into some of those issues, really looking at different ways of using metaphysics to look at artificial intelligence and what it is, what it isn't, and how we interact with it.
Yep. That's cool.
Anything else that we want to think of that we want to cover?
We also want to know how artificial intelligence can help boost our own day-to-day life, in our work, Does it replace a human or not? Or on the other hand, can it enhance the capabilities of the human being in their jobs, So, and if you have any other topic, just put it on the link, on artificial intelligence. We are really going to look into the link and to try to do some episodes around your interest around AI.
Once again, go to thatnerdycatholic.com/AI. Let us know if there's any way that you use artificial intelligence in your day-to-day, whether it's, like we said, to summarize something. There are other models as well. You have the generative AI models that are based more on images than on language. How do you use AI in your day-to-day lives and your work? And so we're hoping to get to some really interesting, robust conversations around this. And as we've said over and over again, what we're doing here, we're not the experts trying to teach all this stuff, because we're not. We're just a couple of nerds that love to learn new things, and we want to be part of a conversation.
Yes.
And so we want you to be a part of this conversation as well. But that's where we have to end for right now. So I want to thank you for joining us again today. If you go over to thatnerdycatholic.com, you can sign up for our email list, get updates on when we put new things out. If you go to thatnerdycatholic.com/AI, as I said, for this series, we have a form for inputting any thoughts or inputs. And we'll be looking at anything that comes in through there, and that is going to help us determine where we go with this series.
Yep.
If you go to thatnerdycatholic.com/merch, you can get t-shirts, mugs, and other cool things that can show the world that you are a nerd and you love going deep into different topics. If you go over to thatnerdycatholic.com/support, you can help support us financially directly. The merch supports us financially as well. But if you want to just help us financially directly, you can go to thatnerdycatholic.com/support. So thank you again for joining us, and we'll see you next time. God bless.
Thank you.
System shut down.